In this video, we'll be discussing the important questions of engineering physics. So let's start with the first module. First module basically has four important topics that are free oscillations, damped oscillations, forced oscillations, and shock waves. So definitely there will be a question related to free oscillations or define SHM and differential equation using Hooke's law. This is a very easy question. And then ready shock tube construction will be there. Applications of ready shock tube will be there. So this is also a must question which is repeated every year. And one numerical will be there based on the formulas which we derive in free oscillation and damped oscillation topics. So coming here, as you can see, damped oscillation, all the three cases. This question is very important. Define Mach number. Distinguish between ultrasonic, supersonic. Yes, this is also very important. And one numerical as usual. So coming to second module basically has black body radiation topic. So Wien's law and Rayleigh-Jean's law, definitely one question will be there. And Schrodinger's wave equation, yes, this is also important. One numerical will be there. Planck's quantum theory of radiation, this is asked every year. And Heisenberg uncertainty principle, yes, this is very easy question. And one numerical will be there as usual. Coming to third module, it is about lasers and optical fibers. So there will be definitely one question about lasers, full form of lasers, and interaction of radiation with matter, Einstein's coefficient, and requisites of lasers, principles and construction of CO2 and semiconductor lasers. So these are important topics from lasers part. So if you can see here, inversion and metastable state, yes, semiconductor laser, this is important. Intensity based displacement sensor with optical fiber, yes, and one numerical as usual. Numerical aperture and optical fiber, and how laser, explain how laser find application, laser application in eye surgery. Yes, this is also important. So V number, modes of propagations, and total internal reflection angle of acceptance, numerical aperture, fractional index change. These are the important topics in module 3. Coming to module 4, it's about classical free electron theory, quantum free electron theory, physics of semiconductors, and dielectrics. So this module is a bit lengthy, but there are standard questions which are repeated every year. So assumptions, yes, this question is a must. And then construction of assumptions, and then Clausius-Mozarti equation, yes, this is also a very easy one. One numerical will be there, which you can easily fetch marks. Hall effect, expressions of Hall coefficient, yes. Electrical conductivity in metals on quantum model, yes, this is also important, and one numerical as well. So coming to fifth module is very easy because it mainly consists of types of microscopes or construction of microscopes, material characterization techniques and instrumentation. So nanomaterials, nanocomposites, and different types of microscopes will be there. So here one microscope is there, X-ray diffractiometer, and then photo electron spectroscope, yes. This is crystal size, this is also very easy topic. And there will be two numericals. One thing which we have to remember in this, in physics as well as chemistry, is that the topics are limited and the numericals are also repeated every year. So there are only a standard set of numericals which appear in the VTU exams. So by solving previous year numericals, you can definitely score 80+ in this exam. Thank you.